Welcome back. We're going to talk about Venn diagrams in geometry today. Pretty much another strange thing that doesn't really remind us of algebra much, but we'll get used to it in geometry. It's all just kind of shapes and interactions and things like that. We're working with Venn diagrams. I already did a little bit of an intro. Venn diagrams are a useful way to show relationships. A lot of times I like to think of them like they're little populations, okay? And we pretty much have three different case scenarios. Either P is entirely within Q. That means every single element of P is an element of Q, right? That means the entire population of P is also a population of Q. We have our typical Venn diagrams, which we're used to, with a little bit of overlap, where some elements of P are also elements of Q. And then we have, there is no relationship between P and Q, just two circles that are totally separate. So to start, really easy start to the notes, we're just going to be either drawing two circles entirely, or one circle inside of another one. We're going to be drawing a little bit of overlap or absolutely no overlap. So question 1 says, students who take chorus also take band. And there's a very important word. Where's my cup? Here we go. We get the word some, right? We're going to be really focusing on words like some or all or there are, because there's a big difference between some students who take chorus also take band versus all students who take chorus also take band. This only says some students who take chorus also take band. So what do you think? Are we going to be, here, we'll give it a little letters here. A, B, C. What type of setup for our Venn diagram we're going to have? A, B, C. I think we're going to be in B. I agree with you. Draw a circle. Let's label this one chorus. And there's a whole bunch of people in chorus, right? And just for the sake of it being the very first question, imagine all these dots are people. You don't have to draw that, okay? But just for the sake of it. And some of these people also take band. So there's another circle for band, but it doesn't want to be totally separate. We kind of want to think about capturing some of these people, right? And there we go. Some of these students do both. And yeah, circles are really hard to draw, so mine are hideously ugly. You'll just have to deal with it, I guess. Number 2, no perfect squares are prime numbers. So we're talking about perfect squares and prime numbers. Outside of that, it says no perfect squares are prime numbers. You think A, B, or C? I think C is how we're going to set this up. Let's see what I can do with my circle here. That's everything I got. That's the best circle I could possibly draw. Not too bad, okay? This is our, oops, get a P there. Perfect squares. And all the way over here, there are prime numbers. And that makes sense. A perfect square is like 3 times 3. So if you can do 3 times 3, then you're not a prime number, right? So 9 is a perfect square and is certainly not a prime number. There's absolutely no overlap between these two things. They're totally separate. All right. Number 3. I imagine that we're going to get our third example here, but let's see. Numbers divisible by 6 are always divisible by 3. So again, look for these important words like some, like no or none, and here we have the word always, which is a good indicator that numbers divisible by 6, that's the first thing that they've given us, okay? Numbers divisible by 6. I don't know if that's even that even makes much sense, but numbers divisible by 6 in that circle those numbers are always divisible by 3. So we can draw a great big circle, and our circle should be completely inside the other one. These are going to be numbers divisible by 3. Another totally true math fact, right? If you think of numbers divisible by 6, 6, 12, 18, 24, 30, 36, all of those are always divisible by 3. All right, so now we've got one of each. So now maybe it gets a little bit more difficult, or maybe it gets easier because now we've seen one of each, so now we have more experience. Number 4, every natural number is a whole number. How do you think we're setting it up? Is it looking like type A, type B, type C? This should be another back-to-back type A, right? With a circle inside of a circle. Which one is the inside circle? Is that natural numbers or whole numbers? Every natural number, all of these natural numbers are all inside of the whole numbers. This is something that you do in like 5th grade or 6th grade or whatever, is you make a giant circle, concentric circles. The natural numbers are inside the whole numbers, are inside the integers, are inside the rationals. Maybe you remember that, but likely you don't. But we're back here again. We've already done a little bit of a question with naturals and wholes. This makes sense. Whole numbers is just the natural numbers. There's only one number outside of this, which is 0. All right. Number 5. Some vertical angles are complementary. Again, you get these little clue words. You think we're going to be set up with A, B, C here? This is going to be, what'd you say? I think it's going to be set up B as well. Circles with a little overlap, right? We got vertical angles. Remember, vertical angles are the ones that are opposites, like A and B here. And the ones that I just drew, maybe they look moderately complementary, but it's really hard to tell. They're certainly not guaranteed to be complementary. I'm gonna run out of room here. I don't know. Look at this. It's like a roller coaster. What a mess. I think that looks great, right? There's a couple perfect vertical angles that are complementary. Last one is irrational numbers are never rational numbers. We get another word like never. So what do we think? A, B, C? This is going to be C, right? We got two totally separate things. You got irrational and rational. I think literally the definition of these numbers or these different categories like contradicts each other, right? Irrational numbers are not rational, particularly. That's the whole point of them. All right, cool. To be honest, this stuff, like typical in geometry, for about 5-10 minutes, we're going to do something that's so easy, so boring, we're kind of snoozing, and then all of a sudden we're going to get somewhere and we're going to add that first layer of difficulty to it, and we don't want to kind of snooze here, okay? Here's the important part. Venn diagrams and logic, right? We're going to bring in the logic stuff. We're going to bring in the symbols, like, if you want a little reminder, this symbol, which means implies, this symbol, and this symbol. Do you know what these symbols mean? We have the and symbol. We have the or symbol. Okay? And of course, we're going to be working with mostly P's and Q's. All right, so these aren't examples. These are definitions. These are like the ABCs at the top. Here we're getting DEFs. If we have a Venn diagram where the circle is all the way inside the other circle, we're going to set this up as the implies. So this is P implies Q. This is all of P's are guaranteed to be inside Q. Then we have this one. Now, the next two, one of them is going to be and, one of them is going to be or. So let's think about this. Which one do we think is going to be and? Which one do we think is going to be or? Which one of these is more picky, right? Is and very picky or is or very picky? And is very picky, okay? And what do we know about and? You have to be both, right? So pause for just a second. If and is very picky, and we know that and means you have to be both, it has to be this one. Because the only people that get shaded is the subset of people that are both, right? When it comes to Q, when it comes to P, you cannot only be P. You cannot only be Q. You gotta be both, okay? When it comes to the middle setup here, the middle setup is fully colored. You're allowed to be only P. You're allowed to be only Q. You're allowed to be both P and Q. This is our OR setup. All right. Now, the top of this back page, these questions can be really simple, they can be really straightforward, and all of a sudden, one of them can just really trick you and just really kind of mess you up. Sometimes they're a piece of cake, sometimes they get crazy all of a sudden. Let's see, let me get a new piece of paper so I don't have any bleed through. Here we go. So looking at this, the very first one, we want to color all of the sections that satisfy this at the top, okay? So we want to circle any section that is Q. So if I label these A, B, C, which sections are we going to color? C is right. But there's more. What else are we going to circle? We're also going to circle B. So all of this is the answer. Anything that is Q is good. So all of this Q is good. Then we can look at 8. And you can see already it's starting to get a little wild up there, okay? Let's decipher what this stuff means. P, okay, sure. Is that an and or an or symbol? That is an and symbol. And then we have our squiggly Q. And that squiggly means not Q. So here's what we need to color in. You have to be P and not Q. So out of these 3 sections, again, I can kind of label them for you, A, B, C. Which sections need to be colored? We have to be P. So I know that C is wrong, right? C is nothing to do with P. So C is wrong. And not only do we have to be P, we have to be not Q. B is a partially Q. So we're going with only A for this question. Nice job, those of you that said it. Only this section. The other two are wrong. You know, if you color those in, it's not right. We got one more. This one is obviously the craziest one, right? We got 3 circles, oh my gosh, and we've got P or parentheses Q and R parentheses. It's a little bit crazy, okay? Here's where I would start, okay? Let's start not inside the parentheses, right? This right here, this is like the middle. We have the left side, we have the right side. In the middle, is that an and symbol or is that an or symbol? That is an or symbol, okay? The or symbol, if we think back to the front, where I got the front, there it is. The or symbol is the one where we're gonna end up coloring more because we're not as picky. As long as you satisfy the left, you get colored. As long as you satisfy the right, you get colored. So we can think about these separately, okay? We don't have to wait and establish, you know, the right side and the left side and make sure they're both true. As long as one of them's true, we're gonna be okay. So if I look at the left side, it just says P. What are we gonna color for the left side? All of P. It just says straight up P. So we're gonna color all of this. So that is the left side figured out, okay? We've done the left side, and because it's or, we don't have to wait to do both of them at the same time. We can just think of one of them at a time. On the right side, now let's get this right. It says Q and R. Which section is satisfying Q and R? Which section is in Q and also in R? It's a little bit tough to kind of describe here. What do you say? So it needs to be in R and Q. In the middle of the Q and R. This is the section that we need here. So this is the only acceptable answer. The or in the middle is telling us that we need to be, the left side works, we can color that. The right side works, we can color that. Okay? We kind of get to think of it as 2 separate things. The right side here, which says you must be Q and R, is talking about this section in the middle that has to be Q and R. Okay? The last thing that we have on the notes, as much as this is weird, like we've pretty much gone through all of our portions here, is to do the backwards version of the first couple ones that we did. So I'm gonna flip back and just look at the front with you. We're gonna do this backwards now, okay? So instead of seeing the sentence, drawing the pictures, we're gonna be seeing the pictures, writing the sentence, okay? And importantly, we wanna use words like some, if there's some overlaps, always or every, if it's a full circle inside of a circle type situation, or no, none, never, if they're totally separate. So, looking at number 10, we have a circle entirely inside of a circle, and if I look at the front, for both of these, we used words like always, like every. So, how do we want to write a sentence that represents 10? Anybody got any ideas? How about we use the word every, just like they did on the front, every angle that measures 60, right? That's this inside part. Every angle that measures 60. What do we know about all these angles that measure 60 inside this small circle? They're also in the big circle. So we've got that. Every angle inside 60 are acute angles. And I think that pretty clearly establishes what we've got here. Every single angle that measures 60 is considered an acute angle. I think that we could do number 11, so we're just going to skip it. It's pretty much the same setup. You're going to use the word every, then you're going to write the inside, and then you're going to, set it up, the word R, and then you're going to write the big circle, right? Again, same exact setup. I think we got it. Let's look at the bottom. Now, when we get to the bottom, it's a little bit different. We have the coloring that we saw on the front, okay? When we include these colorings that we have on the front, to make a sentence about this does take a little bit of strategy, okay? Just like on the front, when we saw the word some and we made overlapping circles, I see that we have overlapping circles. We're talking about the middle part here. So I'm going to use the word some. And I'm assuming that this is what? People who play volleyball, Right, some volleyballs play piano, right? I mean, that sounds strange. But we'll say some people, right? So some people who play volleyball they happen to also take piano lessons. The real key to these questions is think about it for a second, write a sentence, and then read it, see if it makes any sense, okay? Does it make sense that some people who play volleyball also take piano lessons? Yep. Then look at the picture. Does this picture show that some people who play volleyball also take piano lessons? I think this is a perfect sentence. Okay. Now, 13 and 14, to me, this is the big stuff that people always get a little bit stuck up on. 2 questions left, you guys. 2 questions left. For 13 and 14, you want to think of it where we have a very picky amount of stuff kind of concluded here. We have only the 31 months with 31 days included, and nothing that has to do with months that start with J is circled, right? All of this is empty. All of this is uncolored, okay? And so, our sentence, we want to think of this as not whatever we could write. This is not Q. Because that entire Q is empty. So, we're going to say that there are months All right, we're just saying the first one. There are months with 31 days. Of course there are. And because the entirety of this second piece is empty, then we're going to negate that. Okay? We're going to set it up by saying there are months with 31 days and do not. Going to use that word not to negate. And do not start with J. Can anybody think of a month with 31 days that does not start with J? There's plenty of them. August, right? Can anyone think of any months that start with J that do not have 31 days? This one's a little bit harder. January does have 31. June does not, but July does. So, yeah. It's an interesting little setup here. I don't mind this question. All right. Well, we are going to finish this up. Let's do 14, then we'll be done. Or I guess we'll do 14 and 15 really quick. For number 14, we're going to start it off by saying that there are, so we've got what? Art class and freshmen. So there are freshmen. They really want us to use the and word here, but my sentence just sounds dumb. There are freshmen and do not take art class. That's a little silly. There are freshmen, we'll just say who do not, because all of art class is empty. So let's go ahead and negate that art class. Who do not take art class. Nope. Got a little off screen there. Last one. We got it all filled in. We're not being picky at all. Everybody wins. Participation trophies for people in all three categories. This is a nice, easy or statement. Nice, easy or. Everybody wins. We're not being picky at all. So we just need to say left or right, okay? On the left, it says multiples of 7, so we can say, you know, there are multiples of 7. Then we hit them with a big or, because this is clearly an or picture where everybody's winning, right? And I'll just do a nice big one here. Or there are numbers that are, there are multiples of, oh man, I've kind of botched this one a little bit. There are numbers. I need to at least some point say there are numbers. There are numbers that are multiples of 7 or are even numbers. Right? There's a little bit of both, right? There's numbers that are multiples of 7, like 7, 21. There are numbers that are even, like 2, 6. And there are multiples of 7 and even numbers like 14. And we respect all of them. Everybody wins. All right, Venn diagrams. At this point, like, been a little bit of a trek as far as notes goes. On the front, there's 3 setups. Remember, you're going to look for these words that are very important. The logic stuff, some people think the logic stuff is actually kind of fun. Like, I don't know. I kind of enjoy, especially questions like number 9. I kind of enjoy having to really think hard and figure this out. When it comes to writing sentences, just try to use the same words like some or there are. inside here, we can use words like every, and when it's a total overlap, we can use words like or. These are always the ones that kind of trick people up, where we have empty circles. And if we have empty circles, think of it like a negated portion. And so use the word not to kind of make that happen. All right, well, there we go. That is the first look at Venn diagrams. Not too bad.